Good morning. It's a pleasure to visit with you this morning. The talk I'm about to give you is a little bit different than my county talk this year, so I would encourage you to come to one of our county meetings for some more specific information about peanuts. I'll be at least 35 county meetings, so you'll probably have a chance to see me somewhere down the line. But today I just want to focus a little bit more on some things that are going on with Sicklepod that we want you to be aware of, and what we're doing at the University of Georgia to try to help with the potential or not potential problem. If I don't know if any of you in this room have observed, but in my travels all around the state, the last several years I've noticed a lot more late season Sicklepod problems, and I've had growers call me and ask me, do I think that we have potential Cadre resistance in our Sicklepod? And so that's sort of leading me into my presentation today to kind of tell you what we're doing and what we think. And I'm not touching anything, that's going on its own. But anyway, and so I want to give you an update on what I think's going on, what we're doing to see if we do have resistance or not, and where we might go in the future. So I'm going to spend a few minutes talking about Cadre, a few minutes talking about Sicklepod, and then we'll tell you about some of the research that we're doing. You know, if you look at Cadre and what Cadre has done for peanut production since 1996, it's clear it's been one of the most popular herbicides. You can look in this slide and you'll see this is a U.S. Estimate of the percent of acres that are treated with Cadre. If we're talking about Georgia, we're probably upwards of 70% of our acres are treated with Cadre. And so it's a very popular herbicide. It's been a very good herbicide, and it's really helped us control several weed species that we've had difficulty controlling before it was introduced. And I would argue that in the work that I do every year with herbicides and weed control, the Cadre programs that we test are still very strong, as you can see in this picture. Basically, you'll see a post-emergence treatment of Cadre here at about 36 days after planting, following a strong pre-program, and we're doing an excellent job controlling the weeds at this particular location. So it's still a very effective compound. Now, one of the things I thought would be interesting would be to go back and look at some of the research and talk about how effective has Cadre been on Sicklepod over the years, and what were our expectations, or what do we think was going on. And if you look at some of the work that was done in the development of that herbicide, it's kind of interesting. If you look at some of the early work, that it caused only a 67% reduction in biomass in some greenhouse work, and that's strong. It's not, it would be better if it was in 90%, but 67% reduction in biomass. But then if you look at all the control data, and Tim is in the audience today, so averaged over 50 field trials, Cadre gave about 86% control of Sicklepod, or coffee weed. And that would be considered good. It's not excellent, but it's good. And if you think about what happened at that time, we really were struggling for good Sicklepod control. And so when that came along, it certainly was helpful, and it provided enough control for us to do a good job managing Sicklepod. Of course, its main claim to fame is nutsedge, but we also get control of several other species. And here's just another slide from last year. As I go around and visit with growers, every time we have a herbicide failure, it does not mean we have resistance. Herbicide resistance, I like to call it farmer resistance, but not herbicide resistance. And we can talk about that another time. But here's another picture from our research this past year. Everything's the same in these two plots, except the plot on the right did not get any Cadre. And so without Cadre in the system, we can have a little bit of difficulty. Now, of course, if you're a vegetable grower, or you've got rotation issues, or you've got some cotton issues, that's a different story. But certainly it's clear that Cadre, at least in my mind, is still doing a very good job in most situations. So let's talk about what would be the likelihood of Sicklepod developing resistance to Cadre. Everybody in this room, we all have been dealing with Palmer amaranth since 2004. We're all familiar with Palmer amaranth, so I thought we would compare Sicklepod to Palmer amaranth to kind of see what the difference is between those two species. And probably the biggest thing you see that jumps out at you, that there's two things. Number one, Sicklepod is self-pollinated, where Palmer amaranth is cross-pollinated. So when you have a cross-pollinated plant, you have much more chance for genetic diversity in some cases. And then look at the seed number per plant. Sicklepod does not produce near the number of seed that Palmer amaranth can produce. And so for the spread of resistance, obviously when you've got more seed, you can have more resistance, potentially. Now, if you think about Cadre and you compare it to something like glyphosate, you think about what's going on. Generally, we would hope that you wouldn't plant peanuts year after year, but that does happen. And so Cadre is not going out every year, as opposed to, say, something like Roundup that's going out almost every year in a lot of our crops. So there's a difference there. We've been using Cadre since 1996, and that particular mode of action, resistance has developed. That's probably one of the worst modes of action for the potential for developing resistance. About 157 species right now have developed resistance to that mode of action, where only 32 species have developed resistance to glyphosate. All right, so just a comparison between what we know about Palmer and what we know or don't know about Sicklepod. All right, so I want to just spend a few minutes telling you how we try to find out about resistance. You hear it all the time, but you may not know what it takes. It takes a lot of time and a lot of space. And one of the things I don't have is a lot of time, so it takes a lot of time to get samples done. But I thought you might find it interesting what actually has to happen. And I've got a grad student working on this project. He's from Georgia. He's up in Athens right now, completing some of his coursework, so we're kind of in a lull right now in the greenhouse. But first of all, you got to collect the seed, and I'll talk about more of that later. And that seed has to be scarified. I don't know if you've ever actually looked at a Sicklepod seed. It's much larger than a Palmer amaranth seed, but it has a very hard seed coat. And that has to be scarified or it won't germinate. This happens naturally in the wild, either with tillage or weather or insects or some other kind of abrasion occurs, and that's how you get germination. And so you plant them in the greenhouse, you put them in flats, you spray them with Cadre when they get about 2 to 3 inches tall, and then you harvest them about 21 days later. So from the time we plant to the time we harvest, it takes 5 weeks. It takes 5 weeks to do that one run of a particular population. So it does take a little time. And this is what it looks like, and I'm going to show you some more in a minute. This is from some of our work last year, and I don't know if Judd's in the room, but Judd Green from Southwest Georgia has been talking to me about potential resistance for several years. This is actually from his farm. Here's a known susceptible, and that's from his farm. So right now, at least at that location, we don't think there's any issues with resistance. Now, let's tell you what we've done. My colleague up in Athens, Dr. Bill Venzel, I have a research counterpart up there. He did some random surveys about 2 to 3 years ago all over the state. He collected about 20 samples. 5 of those were Sicklepod populations, and he suspects that 2 of those populations may have developed resistance to Cadre. They came from Peach and Taylor County, and he's doing more work to confirm that, to see if that's been real or not. He's also working on sequencing the ALS gene, which would tell us a lot more about the mechanisms of resistance or potential mechanisms of resistance. So that sort of sparked the work, the further work for my grad student. And this is a picture from Bill's work. There's some populations there that were treated with Cadre that they should look a little worse than they do. So that sparked us on to doing some further resistance surveys. And so over the past 2 years, we've collected about 30 additional populations from various counties across the state. As you can see, I've got depicted here. They've come from all over, a lot more in the southwest portion than in the eastern portion, but generally we tried to get a distribution of populations, and you can see where they came from. And here's just a picture where we've collected. I don't know how that shows up out there in the audience, but those are the locations that we collected some more Sicklepod seed to screen those to see if they have what's going on. All right, and again, this is just another picture of what happens when we do that work. Here's an untreated, and then here's Cadre at the labeled rate about 21 days after treatment. And it's interesting, never really completely dies. They just completely stop growing and never go any further than that point, generally. All right. So at this point, we've been able to get to 8 of the 30 populations. That's 27%. Again, as I told you, it takes a long time. And this time of the year, I'm in my truck all the time. So if I'm in my truck, I can't be in the greenhouse. So it's hard to do that. And my students up in Athens. So eventually, we'll get through all these and hopefully we'll have a better feel if there's really resistance or not, or if we do, what the distribution might be. And so none of those 8 populations that we currently screened were resistant. They all appeared to be susceptible. We currently have got 3 more growing in the greenhouse, and hopefully in the next month or 2 we'll have the final results on those, and then we'll continue to screen those as we get time to do it, because once the spring hits, we jump into field mode. So let's talk about sicklepod control then as it stands right now. A couple of things. So why can it be difficult? First of all, the seed remain viable in the soil for at least 5 years. So they're going to be there for a while if you're managing it in other crops. The seed does not need light to germinate, unlike Palmer. Palmer needs light. The seed can germinate from depths of 5 inches, so it's hard for residual herbicides to not that we have a lot of them that control sicklepod, but it's hard for herbicides to control a plant that emerges from a 5-inch depth. We can use cultural practices like twin rows to help us. There's research that suggests that twin rows will help. Not so much information on tillage. It's not clear whether there's results that say it's better in no-till or strip-till than conventional and vice versa, so it's not really clear. Our herbicide options would be Cadre in most cases, but it's got to be applied to a 3-inch or less, multiple applications of 2,4-DB, or paraquat in a non-selective applicator would be our 3 options. And I just want to remind you, I don't think anybody anywhere has ever sprayed a 3-inch tall sicklepod, so just wanted to show you what it looks like. This is where we need to be spraying. And a lot of times, most of our applications will go out after the peanuts or after the sicklepod might be emerging through the crop, which is probably one of the reasons why we don't get good control. I do want to remind you that we used to use these quite a bit more in our early battles on Palmer amaranth. They can be used for sicklepod management. A 50% solution of paraquat in one of these type of applicators would do well later in the season. Now, the last thing I want to just spend 2 minutes talking about is a potential another reason why we're seeing less control in some cases has to do with the way we're currently spraying. You think about what's going on right now in South Georgia and all over, it's very common to see these types of sprayers. They're very large, they're very fast, they're very efficient, they look like fighter planes. I'd like to have one, but I can't afford one, they are very expensive and they do a good job. I had a grower tell me the other day that he can spray 800 acres a day at 18 miles an hour. I don't know if that's a tractor anymore, that might more be like a plane, but so I'm concerned about what's going on. We are looking into how tractor speed influences coverage. Again, I only got a couple minutes. I'll be glad to visit with you later, but we are doing some tests looking at how tractor speed influences coverage and droplet size and that kind of thing. And there are a couple of things going on that I think you need to be aware of. One, and we don't need to get into the math side of this. The only thing I wanted you to know, this is tractor speed going up, and this is coverage. So as tractor speed went up, coverage went down. So that's something we need to work on a little more to see what's going on there and how that might be affecting you if you're an applicator. One of the reasons we might be seeing less coverage has to do with droplet size. As you increase your speed, again, here's speed and here's droplet size. Our droplet sizes are going up. If we get larger droplets, we're likely to get a little less coverage with the larger droplets. So that's one reason why we might be getting less coverage in addition to some other things like drift. I'm going to stop there. We're limited on our time today. I think I've got 1 or 2 minutes. Again, I would encourage you to come to one of our county meetings. I'll get more into specifics about other control programs, some of the other work that we're doing with all the things that are going on in peanut weed control.